In this video, I'm going to solve this question. Obtain the mean and variance of the random variable x, which has a uniform distribution on the interval a comma b. First of all, note that x is a continuous random variable because this is defined on the interval a comma b. And if a continuous random variable x has a uniform distribution on the interval a comma b, then its probability density function is written in this manner. Okay, so this is the probability density function that we have. Now we have to figure out the mean and the variance. So that means we have to figure out the expected value of x. Because we are working with a continuous random variable, the formula that we have for the expected value of x is this. So we have to integrate the product of x and f of x over all the possible values of x. So in our case, all the possible values of x are ranging from a to b. That means in our case, the integration will range from a to b. So over here, as you can see, the integration is ranging from a to b. X remains x, and instead of f of x, we can put 1 divided by b minus a. Okay, so that's what we get over here. Now we just have to solve this. So let's do that. So over here, because x is uniformly distributed on the interval a comma b. Okay, so this is an interval which is already given to you. So b minus a is going to be a constant. Consequently, 1 divided by b minus a is going to be a constant. So we can take 1 divided by b minus a outside the integral. That means now we just have to integrate x. Okay, and the integration of x is going to be x squared by 2. And these are the values that we have to substitute. Once you substitute these values, you will get this. And then from here, you will get this. Okay. Now you can cancel b minus a and b minus a. So the expected value of x will come out to be b plus a divided by 2. So that means if x follows a uniform distribution over this interval a comma b, then the expected value of x is just going to be the average of these two numbers, right? It is going to be a plus b by 2. So you just take the average of these two numbers, you will get the expected value of x, right? That's what we got over here. Now the next thing that we have to figure out is the variance of x. Okay, so let's see how can we do that. To figure out the variance of x, I'm going to use this formula over here. Now in this formula, we already know the expected value of x. We just found it. It is equal to a plus b by 2. Or you can also write it as b plus a by 2. Doesn't make any difference. Okay, so now we know the expected value of x. So the second term is sorted. But before we could find the value of the variance of x, we need to figure out the expected value of x square. Now what is expected value of x square? Well, expected value of x square is equal to integration x square multiplied by f of x, and over here you write all possible values of x. Okay, so you write all possible values of x. The integration happens for all possible value of x dx. Okay, so this is how you can find expected value of x square. Over here, I have also written this in a formal manner that expected value of any function of x is equal to integration that function of x multiplied by f of x. Okay, so that's what we are doing over here. So if we use this, then we can write this over here. So the expected value of x square, over here we have x square multiplied by f of x. F of x is 1 divided by b minus a, and the integration is happening over all the possible values of x, and the possible values of x are ranging from a to b. So we have a to b over here. Okay, so now we just have to solve this. Once again, 1 divided by b minus a is a particular constant, so we can take it outside the integral. That means now we just have to integrate x square. The integration of x square is going to be x cubed divided by 3. After doing this integration, we have to put in these values b and a over here. So you put in these values, and once we solve it, we will get that expected value of x square is actually equal to this. Okay, so this is expected value of x square. Now note that this is not the final thing that we were looking for. The final thing that we have to look for is variance of x. So variance of x is expected value of x square minus expected value of x whole square. Now we know the first term as well, and we know the second term as well. So we are just going to put in the values. Expected value of x square is this. So we put that over here. The second term is expected value of x whole square. So expected value of x is b plus a by 2, and now we have to do whole square of that. The numerator becomes b plus a whole square, which is this, b square plus a square plus 2ab, and the denominator becomes 2 square, which is 4. So this is your first term, this is your second term. You have to subtract these two terms. We can take the LCM and do the calculation, right? And once we do this and solve it further, we will get that variance of x is equal to this, b minus a whole square divided by 12. So basically, if x is uniformly distributed over the interval a comma b, then the variance of x is the length of this interval. So what is the length of this interval? The length of this interval is b minus a. So you find the length of this interval and then you square it and divide it by 12. Okay, and what is expected value of x? Expected value of x is the average of these two. So it is b plus a by 2. Okay, it's a good idea to remember these formulas because in some of the questions you may have to use these formulas directly. Okay, so just remember that whenever you're working with a uniform distribution, expected value of x is just the average of these two numbers, and the numerator of the variance of x is the square of the distance between these two. So the distance between these two is b minus a, so the numerator is b minus a whole square, and the denominator is 12. Okay, so these are the formulas that we have, and that's it for this question.